All right, question number 9. So this is a statistics question, and it gives you some information about a study. Pretty interesting study, actually. I didn't make this study up. It was just showing how exercise really lowers your risk of heart disease. But it wasn't even really exercise. It was just walking, which is, is definitely a good exercise that most people don't think of. So what type of study was this? It was observational because the researchers were just observing these people. They weren't saying, okay, you guys, you go run a marathon, you go do this, you go do that. They weren't controlling things like that. They weren't influencing the participants in this way, in that way, shape, or form. There's not like a placebo going on or anything. They had a hands-off mentality, so it's just purely observational. What sampling method was used? Well, the only thing it really gives you in regards to sampling method is that they were split up into 3 groups based on how fit and strong they were. That is called the stratified sampling method. Looks like this for you visual people, because they separated it into 3 I can't speak. 3 groups. So that's that. They didn't tell you much more about that. What was the sample size? Well, the sample size is how many people were in the sample. They do give you that. It was 482,702 men and women. They don't tell you anything else really about that sample. All right. And then why is sample size important? Well, if I tell you I did this crazy study and it gave you, the cure to diabetes, and it worked for one person, that's awesome, but it's not that powerful yet. We need to show that it works for a bunch of people. There's so many people in this world that we really need a larger sample size to make any important conclusions, especially when your population's this big, because we're just talking about humans in general. So to have a sample size of like 1 would be so small. We actually have a decent sample size here though, with 482,702 people. That's pretty big. So the larger the sample size, the more powerful the study can be. More powerful / accurate. I guess I only used and accurate. But keep in mind, even though a study might have a very large sample size, you got to keep in mind how they got that. So the study the example I've given in class is, what if I went to the basketball courts and asked everyone there their favorite sport, basketball or soccer? Most of them are going to say basketball. They're playing basketball right then and there. So that would be like, okay, well, if I need a really big sample size, I'll go to all these basketball courts and do that. Well, just because you're increasing your sample size there doesn't make your study better, because your sampling method is flawed, right? So the only time the sample size is important, but if your study is flawed, your sampling method is flawed, then it doesn't really matter. All right. Anyways, I know you want me to get moving on here. So number 10, what do the average and median tell you about a data set? Well, they tell you where the middle is. They're used to measure the middle of data. So used to measure the middle or center of a data set. Okay. And this next question is kind of tied to it. When is the median a better measure of the center than the mean or the average? Because as you might think after reading question 10, why do we have both? Like, if the mean and the median both tell you the center of the data, why not keep one and stick to it, right? But there's a reason why we have both. So one of them is drastically affected by outliers. And outliers a number far away from the rest, right? So one of them gets destroyed with outliers. And if you think of this example, I think it will help make this make more sense. So you ever been doing pretty good in the class, getting 80s, getting 90s, and then all of a sudden you don't do one assignment and you get a 0, that 0 being an outlier, well, it crushes your average. Like your overall average, you're looking at, you're like, wait, what happened? I have all these 80s and 90s. How do I now have 79 average, right? And that's because outliers drastically impact the mean or average. So when is the median a better measure of center? When the data set has outliers. Because in the median, you're just crossing off that outlier, just like it was any other number. So it impacts the median, but not that much. All right. Next, what is the standard deviation? What does it measure? What does a larger standard deviation mean? Okay, so there's 2 questions here. Sorry, I'm just checking on my dog. Make sure he's not destroying anything. So the standard deviation measures how spread out the data is. So is all that data clustered together? For example, if I were to give you grades and it was like you had an 80, an 82, an 85, a 79, well, those data points are all super close to each other. So their standard deviation would be pretty small, right? But what if another student was very hit or miss, that 100, 50, 98, 60, that's all over the board, right? The standard deviation would tell you that data is super spread out. It would tell you that by being a very large number. So what does a larger standard deviation mean? Well, the larger the standard deviation, the more spread out the data is. I actually want to add one other thing here. So yes, it measures the spread of data, but more specifically, what the standard deviation is doing is it's finding the average or the mean, and then it's looking at every data point and trying to figure out how far are they away from the average. So the standard deviation measures how far the data points are from the average / mean. All right. This is going to be the last question for this video. Yeah. What time is it? 7? Okay. Yeah. I think this will be the last one for this video. So you have all this raw data, all these grades. A frequency table is an easy way to organize this so that you can try and look for trends and patterns. So what frequency means is, well, how many times did it occur? So this will be fun. Hopefully I nail this on the first one because I have not done this problem yet. So A's, we got 1, 2, 3, 4, 5, 6. B's, we got 1, 2, 3, 4, 5. C's, we got 1, 2, 3, 4, 5. D's, we got 1, 2. So that's right. We'll see in a second. F's 1, 2. A quick way to double check this is figure out how many you should have. So 1, 2, 3, 4, 5, 10, 20. Then add these up. 11, 16, 20. Okay, so we are good to go. Hey, buddy. You want to be on the screen? Come here. Come here. Oh, you don't want to be on? Okay. Well, it's worth a try. All right. I'm going to have to pause.